Hello everyone, welcome to Josh Max channel. In this video, we are going to see CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in Exercise 5.1 11th Sum. So already in the last video, still question number 10, I have uploaded the solution. So please do check. Now let's move on to the 11th Sum. So what is the question is about? Find all points of discontinuity of f where f is defined by. So our question is demanding us to find the discontinuity, okay, for the given function. So where that particular function at what point is getting discontinuous. So this is the given function. So f of x equal to two different functions we have under two different conditions. So x cube minus 3, this particular function we have to use if x is less than or equal to 2. And the second function we have to use x is greater than 2. So throughout the real line, we are not going to use a single function. So based on the conditions, we must have the cases. So using the if condition, let's break the real line. So now at x equal to 2, whether function is continuous or not, we are going to check. Now if x is less than 2, so in this case we are going to check function is continuous or not. Then if x is greater than 2, and while checking if x is exactly 2, so not only at 2, the close values of 2 as well we have to check with the help of limits. Now same way if x is less than 2, so less than 2 we have infinite real values lies in this particular interval. So let's have a common name. Then f of c, the closed values of c in the left hand side and closed values of c in the right hand side, with the help of limits we are going to check. If everything coincide, then we can say throughout the interval the function is continuous, so there is no point of discontinuity. Now similarly we have to do for this interval as well. So that means to check the continuity or to find the discontinued point for the given f of x, we must have the three cases. Okay, so let me take the case 1 as at x equal to 2. Okay, so case 1, if x is exactly 2. Okay, so first let's find exactly 2, f of 2. So suitable function from the given we have to choose. The suitable one is first function. So in place of x we have to replace 2. So 2 cube minus 3. So 2 cube is 8. 8 minus 3, which is 5. Now same 5 are we going to get for the close values of 2 in the left hand side as well as in right side, we are going to check. In case if all the three values coincides, f of 2, left hand limit of the 2 and right hand limit of the 2, if everything coincide, then we can say at x equal to 2 the function is continuous. So it's not a discontinue at the x equal to 2. Okay, now left hand limit. See left hand side the close values of 2 infinite values are there. Okay, so with the help of limits only we can able to find out approximate values of the limit. Okay, so now limit x is approaching to 2 from the left hand side. To indicate that we are approaching for the left side values, we have to indicate with the minus sign. Okay, now f of x. So suitable function, all values close to the 2, approximately 2, but anyway it's less than 2. So suitable function is first function. So we replace f of x with the first function. First function is x cube minus 3. And as I told you that all close values are approximately 2. So directly let's replace x as a 2. So 2 cube minus 3. So 2 cube is 8 minus 3, which is 5. Now let's find out for the right hand limit as well for the 2. Limit x is approaching to 2 from the right side. Okay, from this side it's approaching. So all close values of the 2 is approximately 2 but greater than 2. So suitable function from the given is the second one. So replacing f of x with the second function, that is x square plus 1. So replacing x as a 2, that is 2 square plus 1. 2 square is 4 plus 1, which is 5. Now we can notice that f of 2, left hand limit and right hand limit, all three coincide. That means at x equal to 2 function is continuous only. Okay, and now we have to check in this particular interval, that is if x is less than 2, how the function, is there any discontinuity happening or not, we are going to check now. If x is less than 2, so case 2, if x is less than 2. Okay, if x is less than 2 means infinite real values are there. So one by one for every value, every single value, it's not possible to find out. So let's have a common name as I told you in before. So let's have a common name as a C. Let C be the any real value, condition applies. Let C be any real value. At the same time, it should be less than 2. Now f of C value, okay. So C can be anything, okay, any value in this particular interval. So we have to find out f of C and closed values of the C in the left side as well as right side we have to find out. So first for the f of C. So what is the C that we have taken? Less than 2. If it is less than 2, suitable function is the first one, that is x cube minus 3. So here input is C, no? So that means C cube minus 3. Okay, next left hand limit, right hand limit. So let's understand before finding left hand limit, right hand limit individually is required or not, let's study. So now the left hand side closed values of C also less than 2. So that means in place of f of x, since it's a less than 2, we are going to use the first function. Now same way right side closed values of C also less than 2. That means while in the process of finding the right hand limit in place of f of x, since it's a less than 2, we are going to choose the same first function. Okay, on applying the limit, if the function is same, on applying the C, it's going to be same outcome only. So instead of finding the left hand limit, right hand limit separately, once we come to know the f of x is going to be same, then instead of finding it separately, we can find it together. Okay, so now left hand limit, right hand limit together, limit x is approaching to C. There should be no indications here. Minus means left hand limit, plus means right hand limit. So if there is no indication, it can be understand that it's for both. Okay, so f of x, the suitable function as I told, it's going to be a first function. So replacing f of x is x cube minus 3. Now applying the limit c cube minus 3. So from this what we can say, f of c, limit x is approaching to c, f of x is same. So even in this particular interval, there is no point of discontinuity. Now finally we have to check for, in this case, if x is greater than 2, how the given function is reacting, that we are going to see. So now case 3, if x is greater than 2. So greater than 2, we have infinite real values false in this particular interval. So let's have a common name. Let C be the any real value. Let C be any real value. Condition applies that C should be greater than 2. Now exactly C. Okay, since C is greater than 2, suitable function. Second one, x square plus 1. So our input is C, so C square plus 1. Now left side close, right side close values of C are greater than 2. So that means limit together we can find out limit x is approaching to C, f of x. So suitable function C square, sorry, x square plus 1. Now applying the limit, this becomes C square plus 1. Now f of C, limit x is approaching to C, f of x, both are same. That means even for this function f of x, there is no point of discontinuity. Okay, throughout the real line it's continuous. So f of x is continuous for all the real values. So there is no point of discontinuity. So that's how the solution. Okay, thank you for watching and please do subscribe. And 12th sum, in the next video I'll be uploading the solution for the 12th one. Thank you.